Okay, in this video clip we're going to look at Ohm's law and how to do some basic calculations using Ohm's law. So first up, let's have a quick little look. I'll just zoom in here a little bit. Ohm's law, the easiest way to remember it is to remember this triangle. V at the top, IR across the bottom. Because using this you can generate any of the formulas that you'll need to answer these problems. So for instance, we can rearrange the triangle. The way it works is the one you're trying to find out, so if you're trying to work out voltage, you cover that up with your finger. You cover that one up, and so voltage equals, and you look at what's left. And if they're side by side here, then it's I, the current, times the resistance. And if we wanted to know, for instance, the resistance, we'd put our thumb over that. And so resistance equals, and it's now voltage divided by current. And we spoke about that one in the last video. We said if we've got a big voltage, say like 10 volts, but so we've got a 10 volt battery, but it's only giving us a little current, 1 amp, there must be a fairly reasonable big resistance. So 10 divided by 1 would be 10, whereas we said if it's the other way around, if we've only got a small voltage, say 1, but that gives us a decent current of, let's say, 10 amps, that would be 1 divided by 10 is 0.1. The resistance, you can see, is very small. We're getting a large current, even though we're only applying a very small voltage, giving the electrons a very little amount of energy. And lastly, there's one more way we can arrange this formula, which is we can put here, what do we need? I current. The current we get is equal to voltage divided by resistance. And again, this one makes a lot of sense too. The current, if we crank up the voltage, so if I have 1 divided by 1, that would just be obviously equal 1. But if we crank up the voltage, if we make that 10, alright, then suddenly increasing the voltage proportionally increases the current. Increasing the voltage by 10 times, giving it 10 times the voltage will give us 10 times the current. And again, the other way around, increasing the resistance. So if we had a 1 volt, 1 ohm resistor here, increasing the resistance, if we increase that by 10 times, so we make that 10 ohm resistor, suddenly the current is 0.1. So increasing the resistance by tenfold would reduce the current by tenfold. So this shows that inverse relationship. Making the voltage bigger gives us a bigger current, but making the resistance bigger, it opposes the flow of electrons, we get a smaller current. So again, it just shows that relationship. But the easiest way, if I've just confused you a whole lot there, just remember your little triangle here, and when you need one of these, then you can get the formula you need. So let's go through and do a couple of these problems. Now, the really important thing here is that you need to show working, and you need to show the answer with units. And I've worked at schools where there are marks for the working and for the unit, and maybe only even one mark for the answer. And so you might even be able to pass even if you've got the incorrect answer. If you've shown the correct working, you've just made a mistake. So basic problems like this first one, we've got a 12 volt battery and there is 2 amps going around the circuit. And remember, if we've got 2 amps on one side, we'll have 2 amps on the other side too, because the current isn't used up, it's not consumed, it just goes round and round and round. That's the flow of electrons. But what is, in this case, we want to work out the resistance. We're being asked for the resistance. So in this case, we're working out what is the resistance of this resistor. Since there's only one resistor in there, it's basically asking us what is the resistance of this resistor down here. So using my triangle, if I cover up R equals, alright, V voltage divided by current. So in this case, that is, we've got 12 divided by 2, alright, and that equals, in this case, we've got 6. So the resistor must be 6 ohms. And ohms has, oh, it didn't work so well, has that symbol, the omega, the symbol omega. So to get the full marks here, it's showing you working, so write the formula, show the working, what numbers you're dividing by what, or timesing, whatever you're actually doing there, the answer, and the unit. So it might look like there's not much there, but it's the formula, the working, the answer, and the unit, or the symbol. So the working for this next one over here, we're being asked for the current. So current, in this case I, and feel free, if you're finding these easy peasy, just fast forward and go on to the next ones. I equals V divided by R. So we've got a voltage here of 12, voltage here of 12, divided by a resistance of 3. So our current will be 4, and the symbol is amps, which is a capital A. And it's really important, guys, if the symbols are capital or lowercase, you've got to pay attention to that. You can lose marks for having that the wrong way around. So the last one here, we're being asked for the voltage. So voltage equals current I times resistance, which in this case is 3 times 3, and so the voltage must be 9, and it's volts. Okay, so the battery must be spitting out 9 volts, or there'll be 9 volts lost across this resistor here. Okay, so it is really just a matter of when you're using your triangle here, cover up the one you're trying to work out, the one that hasn't been given to you. So you cover up that one. If that's what you're after, it must be V divided by R. If you're covering up V, if you're trying to find out what the voltage is, then we cover this one up, and it's I times R. Okay, let's get on to the next ones. Get some a little bit more tricky. So if we look at here, just scroll that up. Sorry, a little bit of lag there. So if we look at this one here, I'll zoom in a bit too. What is the voltage drop across each resistor? So before we do any calculation stuff, let's just think about this logically. Electrons are flowing through here. They're picking up energy through these. We've got 2 batteries here actually, but they're picking up 12 volts, and then they're going through this resistor and this one. And the resistors are identical. They're both 3 ohms. So if the electrons are picking up 12 volts, remember in a series circuit, the voltage is shared between the resistors. So the energy that's lost by the electrons, the energy they're carrying, half of it will be lost here, half of it will be lost here before they come back and pick up another 12 volts. So what does that mean? Without doing any fancy calculations, essentially what we're going to say here, the voltage drop, because those resistors are identical, we'll have 6 volts lost across each one. The electrons pick up 12 volts, they lose 6 across here, they lose another 6 across here, they come around and they pick up another 12 volts. What is the current flowing through the circuit? Well, what we can do is we can work out the current flowing through one of the resistors. So we can work out the current flowing through, say, this resistor here. So again, we use our triangle. So we say V, I, R is our triangle. And in this case, I want the current. So I say current equals voltage divided by resistance. And so in this case, it's 6 volts, because remember the voltage drop across one of these resistors was 6 volts. That was the first part of the question, and that's the trap. If you got asked 8b without 8a first, would you have thought, oh, I just go with 12 volts? So you've got to realize here, if we're measuring the current flowing through one of the resistors, all right, or one point in the circuit, we would have to look at, okay, so here through this resistor, we've actually got 6 volts being lost across a resistor that is 3 ohms. And so the answer there would be 2 amps. Alright, now there is another way you can do it. You could look at the total voltage, so that would be 12 volts, oh sorry I forgot the one there, 12 volts divided by the total resistance. It would be both resistors then, would be 6 ohms, 12 divided by 6. It actually gives you the same answer, as it should. So I think it's the best way to do it, the easier way I think for you guys is probably just to do it the way I did first. So if you're asked what is the current flowing through a circuit, just pick any, it must be a series circuit, just pick any point. Or usually a question will probably actually say, for instance, like what is the current flowing through resistor A, or might just be next to it like point A in the circuit, and just work out, well, the current in a series circuit is the same at every given point, so work out, say, what's going through this resistor here. If it's got a 6 volt drop across it and it's 3 ohms, well, use our formula here, 6 volts, 3 ohms gives us 2 amps. Okay, so you just had to be aware of this first bit, that even though it says 12 volts up here, we're actually losing 6 here, and we're losing another 6 volts across here. So you can't just use that 12, you've got to be aware of that. Alright, the next one here, 9a. What is the current flowing through one of the branches in point A? So we've got a parallel circuit here, and it's asking us what is the current that's flowing through one of the branches. So here, say point A. So again, if I'm trying to find out what the current is here, well, let's look at our formula here. So again, current equals voltage divided by resistance. So we know the resistance here is 3 ohms. So I can already put that in. It's going to be divided by 3. But what is the voltage drop? So in a parallel circuit, remember, if the electrons come here and they pick up 12 volts worth of energy, well, they either go this way or they go that way. But the packet of electrons that are carrying those 12 volts, if they go through here, they will lose the full 12 volts, come around and pick up another 12 volts. This time they might go the other way and lose 12 volts here, come around, pick up another 12 volts, might go back around this way, lose 12 volts here, but we will have a drop of 12, the full 12 volts across there, and that's just coming back to, in a series circuit, the voltage is split, half the energy is lost here and then half it's lost here. In a parallel circuit, each bulb or resistor receives the full voltage, because half the electrons go each way, but the full energy they're carrying will be used or lost at that resistor. So it's 12 divided by 3. The current is 4 amps. And you can see in this case the current's a lot higher in the other one, and that also explains why, if these were bulbs, they'd be a lot brighter, and why the battery goes flat quicker. And it makes sense that the electrons are flying faster when they've got 2 parallel ways to go around, rather than all the electrons having to go through one and then the other. So what is the total current returning to the bulb? So if the current in this branch is 4 amps, we can assume the current in the other branch is 4 amps too. I mean, it would be the same calculation. We've got 12 volts across there too, and 3 ohms. So if I've got 4 amps in this branch, just draw it over the A, and I've got 4 amps in this branch, what's the total current at point B? Well, the electrons have split, but they'll join back together when they come back. Or if you go the other way around, that's the full amount there, splitting down each branch. So we must have 8 amps flowing out of the battery and returning to the battery. So again, it's just applying that knowledge that in a series circuit, the voltage gets split, but the current remains the same throughout the entire circuit. And that in a parallel circuit, the voltage, each branch gets the full voltage, but the current is split. Half the electrons go one way and half the electrons go the other way. And once you've figured that out, and once you've applied that knowledge, you can very easily work out, actually solve the problem. So the voltage, the current flowing through one of the branches, well, this resistor gets the full voltage, 12 volts divided by 3 ohms, using the formula. gives us 4 amps. We know if we've got 4 amps in each branch, that must combine and we'll have 8 amps returning to the battery. Cool, alright, let's get on to a couple more, the trickiest of the bunch. We've got just a couple more down the bottom here. Just scroll those up. So what is the voltage drop across the resistor labelled A? Wow, this seems really mean. We've got here one that's kind of in series and then 2 that are in parallel. So it seems like, oh, that must be really mean. But I just want you to think of it, come back to our analogy and really think of it like that. So imagine there's a person leaving the battery here. And I know you may have been taught to come out of the positive terminal, but it really doesn't matter which way around you go. You should get the same result when you're doing these problems. So anyway, we're going to pretend we're going around the other way. It doesn't really matter. And as we go around, remember, if you were these electrons coming around here, so the electrons are like the people, and they're carrying energy. So if you came through, and after you've gone through this resistor here, it says here that there's a 4 volt drop through this resistor. So what would be the voltage that the remaining energy that you'd have? Well, you could think of it as though you had 8 left over here. So once you'd gone through this one, your bag still had 8 volt, would still have 8 volts worth of energy in it. So what happens? Well, some of them are then going to go this way, and some of them are going to go off this way. So it doesn't matter which way you go, assuming these resistors are all the same. Okay, you'd have to assume these resistors are all the same. But when you split, at least these two are the same. When you split through these 2 branches, if half the electrons go this way and half go this way, well, the voltage they're carrying, each of them is going to get the full voltage. So actually, in fact, even if they're not quite the same resistor, it shouldn't matter. They should still actually get, yeah. So, sorry, let me make that clear again. So we're coming around here with our sack full of energy. So that's the voltage we've gained from the battery. And as we go through this resistor, we lose 4 volts. We get a voltage drop of 4 volts. So essentially the electrons should still have 8 volts remaining. And when they go through this one, if they choose to go this way, they'll lose that full 8 volts before they return to the battery. And if they come around, they pick up 12 again. They come through this one, they lose 4, so they've only got 8 left, and they might go the long way this time and go through here. They'll lose, because they lose all their energy before returning to the battery, they must lose the remaining energy, the 8 volts, at either one of these resistors. So in this case, resistor A here, the voltage drop across there must be 8 volts. Alright, because any electrons coming through here, they've lost 4 volts here, they're still going to be carrying 8 volts worth of energy, and they've got to lose all of that energy before they come back to the battery. So what is the voltage drop across the resistor labelled A? The answer is 8 volts. And if we wanted to show our working, it would simply be saying we've got 12 volts minus the 4 equals, we've got 8 volts remaining, and they've got to be used up before we get back to the battery. So one more time. Electrons come down here, they're carrying 12 volts of energy, lose 4 here, and then either go this way and lose 8 here, or they go this way and lose the remaining 8 volts here. Alright, we've got one more to go. Just scroll up a little bit before we do that. What is the resistance of resistor A? Ooh, okay, a little tricky one here. So I do my formula. Okay, and we go resistance. Alright, so I should do the triangle V IR. V always at the top. And in terms of the triangle, which way around I and R are, whether the I is on the left and R, it wouldn't actually matter. So you just got to remember that V is at the top. And if maybe you can remember V is like the point of just the upside down, the point of the pyramid. So that's why V goes at the top. Maybe that'll help you. But anyway, if we look at that, R equals V divided by I, voltage divided by current. And so in this case, we need to know what is the voltage drop across this bulb? What's the voltage? Sorry, that's a resistor across this resistor. What's the voltage drop here? And what is the current flowing through there? What's the current flowing through there? So firstly, if we look at it, what's the voltage? Sorry, we should assume for this one, it's carrying on from the example before, that we have our 4 volts being lost here. So we assume our 4 volts is being lost here. I should have put that into the worksheet. Maybe I'll correct that actually. So if we've got 4 volts lost here, what's the voltage drop we'll have across here? So that was our 8 volts. So the voltage drop here was, draw it over the top, was 8 volts. So my voltage might be 8, right? And then we need to know the current. And so again, I could just use this 4 amps, but hold on, would that be right? Let's think about this. If I've got 4 amps worth of, electrons flowing, if that's the rate at which the electrons are flying through here, what happens in either of the branches? Well, half the electrons go this way and half the electrons go this way. So we've just got to remember that the current is split between the 2 branches. So if I've got 4 amps here, I would have 2 amps in this branch and 2 amps in this branch. And then after the resistors, what would the current be here? Well, they join back together, the electrons. Remember, they're not used up, so we'd actually have 4 amps coming back around this way. Okay, so again here, then we can say, well, we've got that 8 volt drop. We worked that out in the problem just before. And the current here would be, we've got a voltage drop across that resistor of 8 volts, and we've got 2 amps. We've got 2 amps going through that branch. And so our answer is it must be a 4 ohm resistor. 8 divided by 2 is 4, and ohms is just the unit, the symbol for resistance. So I hope you found that helpful. Some tricky problems in there too, I know. So good on you if you were able to get through those. And hopefully you found this video helpful if you found those problems a little bit tricky. And that's it.